All right, in our second example, we're going to show partial fraction decomposition again. Now this one's a little bit more complex. Not that it's harder, it's just that there's a couple more parts to it. So, we have this equation, 5x squared minus 7x minus 2, all over x to the third minus x. First thing we have to do is we have to factor that denominator, okay? So, we're going to factor that denominator. I might say, okay, well that's really, x squared minus 1. Well, and we know that's difference of squares. So we're going to rewrite this, right? 5x squared minus 7x minus 2 over x plus 1, x minus 1. Again, I did difference of squares of x squared minus 1. Separate them that way. So in my partial fraction decomposition, the way we write this, it's always a over x plus b over x plus 1 plus, now we need a c term, c over x minus 1. So we just kind of keep going. As many factors there are in the bottom, that's how many different components we're going to write for that partial fraction decomposition. Okay? Well, my goal now is to solve for a, b, and c. That's our ultimate goal. The first step we always do when we get into the solving process is we're going to clear out the denominators. We multiply the entire equation. So it's multiplying every single part on the inside of these brackets by the common denominator, which will always be the original denominator, by the way. Now, remember, when I multiply this, it's going to cancel out the entire denominator. So my left-hand side is just 5x squared minus 7x minus 2. Now we kind of just need to look at what's going to cancel out. Well, x and x is going to cancel out, right? So I'm going to have a times x plus 1, x minus 1. We'll multiply this out on the next line. X plus 1 is going to cancel out that x plus 1 there. So I'm just going to have b over, or times rather, x minus 1. This x minus 1 is going to cancel out that x minus 1. So we're going to have c times x plus 1. Now, the next couple lines is really just going to be me simplifying, just doing basic algebra for simplifying. So, first and foremost, I'm going to multiply my x terms, and then I'll distribute the a, b, and c. So, a, x squared minus 1. Okay. I'm going to multiply my x terms, b, x squared minus x, c times x squared plus x. Let's distribute our a, b, and c values. We'll get ax squared minus a plus bx squared minus bx plus cx squared plus cx. Now, if you recall from our previous example, now I'm going to just rewrite these a, b, c, and x terms. I'm going to write them almost in descending order. I want the x squares together and the x terms together and the constant terms together. So I'm going to rewrite this as ax squared plus bx squared plus cx squared. That takes care of this. Now I'm going to get minus bx plus cx minus a. So see, I just rewrote it. I have all my x squares in front, my x's together, my constant together. All right. Very last thing. I'm going to factor out an x squared. A plus b plus c, factor out an x squared. This line is the same as the line as above, right? Because I could just distribute this x squared and it's the same exact as above. So that's kind of the move we're doing. We're factoring, it's like the reverse of distributive property, right? Just factoring out a GCF. I'm going to also factor out a x term right here. We'll have negative b plus c. Really, that minus should be on the outside, I suppose. So let's make this like that. That's really how it should be written. We'll make that plus a negative b. X and minus a. My left-hand side is 5x squared. So the left-hand side hasn't changed. So the left-hand side hasn't changed this whole time. But now we get to match things up to create a system. The coefficient of x squared must match the coefficient of x squared. Therefore, 5 has to equal A plus B plus C. The coefficients of x have to match the coefficients of x. Negative 7 equals negative B plus C. The constant must match the constant. Negative 2 must equal negative A. Well, we see one that's very easy to solve, right? Look at that last one. Negative 2 equals negative A. So that, therefore, 2 equals A. All right? 1 out of 3 solved for. Let's get the other two now. So I'm going to use that first and second equation there. I'm going to substitute 2 for A and rewrite and kind of solve a system of equations. So let's check that out. I'm going to take this 2 and I'm going to substitute it back into this first equation. So that would be 5 equals 2 plus B plus C, which would lead us to write 3 equals B plus C. Subtract 2 from each side. I'm going to drop down this next equation. Negative 7 equals negative B plus C. We're going to solve using elimination. Conveniently, the B's already set up for elimination. Oh, don't cancel that out. This is negative 4 equals 2C, or C equals negative 2. Well, we know what A and B are. We know what A and C are. Now let's solve for B. Take this A and C term and plug it back into the first, or we can use a second equation. Doesn't really matter. So use that second equation right here. We would have negative 7 equals negative B plus negative 2. Therefore, negative 5 equals negative B, or 5 equals B. And all I do is add 2 to both sides and then divide it by negative 1. These are my A, B, and C terms. Typically, we would rewrite the answer, but fortunately for me, I'll just do it in marker. So really, I would say rewrite your answer properly, like rewrite this completely underneath. But for our sake, we'll just say our answer is A was 2, B was 5, and C was negative 2. Okay? There you go. That's your second example of solving partial fractions. Our work today is going to be on Math Excel. And make sure you guys look on page 834. I think it does a good job of solving it, as well as review these videos. All right. Talk to you guys later.